Hey everyone, in this lesson we are going to begin setting up our tile map. Now a tile map is basically going to be the tiles that we combine together to create our level, okay? It's going to have collisions so our player can walk along surfaces, jump over gaps. So let's get started on setting this up. So first thing we're going to do is open up our content drawer right here, and we're going to go over to sprites. And then on our tile map texture here, which as you can see contains all of our individual blocks, we're going to right click, we're going to go up to sprite actions and go to create tile set. Okay, and we have our tile set right here. We can then double click on it to open it up in its individual window here, which we can just dock. Now, what is a tile set? Well, basically a tile set is sort of a collection of sprites that we can then use to build a tile map. Okay, you have a tile map and a tile set. A tile set, like I just said, is a collection of different sprites we can use to build a tile map. And the tile map is basically the final image which we are combining sprites from our tile set. Okay, so it'll make a bit more sense when we continue on, but pretty much what we got here is our tile set, and we do need to change a few things here. First of all, you'll notice that if we click on our tile set on the left-hand side, we can see the individual sprites we have, but as you can see, they're pretty big, okay, and not really matching up with our grid we have here. So what we're going to do is go over to the right-hand side, and where we have tile size, we are going to basically set this to be the resolution of our tiles right here. So we're going to change this from 32 to be 18 by 18. Now you can see that we have this white outline around our first sprite, which is very nice, and we can see on the right-hand side what that sprite looks like. But when we click on the next one, you can see that they're basically offset, okay, and they're no longer working. And the reason why is because there is a 1 pixel gap between all of our sprites here. So we need to then go down to where we have our per tile spacing and set that to be 1. Now, all of our sprites should be nice and cut out exactly in the dimensions and positions that they should be. Okay. Now, the next step is going to be setting up collisions, because if we were to create a tile map with these tiles, add in our player, they would just fall straight through the map because the game doesn't know which tiles we want the player to be able to collide with and which ones we don't want them to collide with. So what we're going to do is we're going to select a tile here, and we are going to, first of all, go up to where we have the colliding tiles button up here to enable that. And this is basically just going to show us which tiles have collisions. So we'll select that first tile here, and then we'll go to the add box button right here, and that is basically going to add a blue box here, and on the right hand side we can see exactly that box. Now this box is basically defining the collision of this tile, so when a player falls down, they are going to basically be standing on this box. Now we can go through each of our other tiles that we want the player to be standing on, click add box, and go through that process for each and every one of them. Now, you can go ahead and do the rest for all the others if you wish, but I'm just going to do these ones for now because we're only really going to be using these tiles throughout the course, but if you want to have all these other tiles added, you can of course go add colliders to those as well. So, now that we have everything set up, we can save it by clicking on the save button at the top left corner or going Ctrl S on your keyboard, and then we can go back into our main level scene here. We can then open up the content drawer, and what we're now going to do is create a tile map using that tile set. So to do this, we're going to right click on our tile set and go up to where we have create tile map. And we're going to call this one our tile map underscore level 1. Now we can double click on this to open it up, and you can see what we have here is basically a window where we can then draw our tiles out. So on the left hand side we have our tiles set, which we can zoom in and click on tiles to select them. So I can click on a tile here for example, and then on the right hand side we can click and drag to basically paint it in like this. Now the first thing you're going to notice is that we have a very small area to paint, okay? We only have 4 by 4 pixels. So we need to increase the size of our tile map, and to do this we can go on the right hand side to the details panel and down to where we have map width and map height. I'm going to change the width to be around, let's just say 30. We'll probably bump that up to about 40 actually. And we'll set the height to be about, we'll go 15. So there we are. This is what our map is going to look like. And now we can go ahead and begin painting in our tiles. Now, a few tools we have. First of all, the paint tool, which we have set by default here on the top left. We can click and drag to paint or click to add in tiles. We also have the eraser, which can be used to basically erase tiles, and fill, which we can use to basically fill in voids with the selected tile, okay? Now, I basically want you to go ahead and start drawing out your levels, okay? So we can have a little platform here for the start of the game where the player goes. We might then have a jump for them to make over here. We might then have some other little platforms right here that the player has to go to. And yeah, basically draw out your level, and I'll be right back to see how you're done. Okay, and there we go. So now we have our level basically blocked out, just waiting for us to add in the player, the coins, the enemies, the end flag. So now what we can do is save this. We can then go back to our main level, and what we're going to do is we're going to open up our content drawer, and we're basically just going to drag in our tile map into our scene here. So, first of all, we need to center it so it is in the center of the world, and to do that, we're going to go to our details panel, and set the location to be 0, 0, 0. Okay, and here it is right here. So we have our level. Now if we press play, you can see this is what it's basically going to look like in-game. There are a few things that we do need to change, of course, when it comes to the visuals, such as adding in a background. So let's actually go ahead and do that now. For our background, what we're going to do is we are going to open up the content drawer, and we are going to create a brand new material right here called background material. Now this material is basically just going to be a flat blue color, so we're going to double click on it to open it up inside of the material editor, and pretty much we're not going to go into too much detail about the material editor right here, but basically we're going to create a color parameter, so we're going to create a vector 4, constant vector 4 right here. And this here, if we double click on the black square, it's going to open up a color picker where we can enter in a color. So I'm going to choose this sort of light blue sky color, click OK, and then we are going to go down to our details panel, change the shading model from default lit to unlit. So this basically means it's not going to utilize any of Unreal's lighting, and then we can plug in this white node over here, so we're going to click and drag into emissive color. And that is basically just going to make this material a flat blue color. We can hit save, we can go back into our level here, and we are going to create a new object. So if we go over to place actors, we can search for a plane, drag that into our level right here, and if we go to our content drawer, we can drag on that material so it is applied like so. Then we can go ahead, we can rotate our plane so it is facing vertical. We then want to scale it up, so I'm going to go down to scale here and set this to be about 100 by 100 by 100. And we then also want to move it back a bunch, just so nothing accidentally goes behind our background. And let's also rename this to be background, so we'll right click on it, we'll go over to edit, rename, and we'll call this background. And there we go. So now if we press play, it's going to look a bit nicer here, but of course there are a number of things we need to do, such as adding in a player, changing our camera, and also modifying a few settings, which we will get into in future lessons. So thanks for watching, and I'll see you all then in the next lesson. Hey everyone, in this lesson we are going to be setting up our player character. Okay, so to begin, we're going to open up our content drawer. We're going to create a brand new folder here inside of content. We'll create a new folder. This one is going to be called blueprints. And inside of here, let's create ourselves a brand new blueprint. So we'll right click, we'll go blueprint class, and we want to find ourselves a 2D player controller. So to do this, we're going to open up all classes, and I'm just going to type in paper. And you'll see here, if we scroll down, we should have a paper character. Now this is very similar to the character blueprint, which is used to basically have a character that we can control and move around, but in 2D form instead of 3D. So we'll select that, we'll rename this to be our player, and then we can open it up by double clicking. Now, inside of here, it's going to look a lot similar, or it's going to look a lot like the default character blueprint, except for one thing, and that is instead of a mesh, we have a Sprite flipbook component right here. Okay, so in terms of that, let's go ahead and create our player sprite. So I'm going to open up the content drawer, I'm going to go to our sprites folder, characters, and let's just say we want to use this yellow character right here. Well, first of all, before we actually can use this image, we have to convert it to a sprite. And we have 2 of these for a little walk cycle. So I'm going to select both of them. I'm going to right click and I'm going to go Sprite Actions, Create Sprite. So now if we scroll down to the bottom, you should see that we have these 2 objects right here, which are of type Sprite. So these can actually then be used. And we're going to create 2 animations. We're going to create a walking animation and an idle animation. So to create the walk animation, I'm going to select both of these sprites here. I'm then going to right click and go create flipbook. I'm then going to call this player_walk. And as you can see, when we hover over it, our player is playing its little walk animation. But one thing you may notice, and that is it is going very fast. So let's slow that down. We can double click to open it up. And you can see, yeah, the animation is playing and it is flicking between these 2 sprites way too fast. So what we can do is we can open up the keyframes, drop down here on the right hand side, and this is going to basically show us each sprite it is going between and how many frames it is holding onto it for. So I'm going to bump this up to maybe 5 each, and as you can see, our animation is slowed down a bit. We can then maybe go ahead and change the first one down to maybe 2, maybe this one down to 4. Or 3 and 2. And yeah, there we go. Just mess with these settings a bit, change the frame runtime until you have a walk animation that looks nice. So we can then save that, go back into our content drawer, and now let's create our idle animation. Now the idle animation is going to be pretty simple. It's just going to be this first sprite where the player's legs are standing still. Right click, create flipbook, player_idle. Whoops, need to rename that. Player_idle, and you'll notice when we hover over it, it doesn't change, and that's because we are only using 1 sprite, so we don't actually need to go in and modify anything with this. Now, what we can then do is go back to our player blueprint right here, and on the sprite component, we're going to select that, and then in the details panel, go down to where we have our source flipbook, and set this to be the player walk. And as you can see, we then have that sprite existing and playing, which is very nice. But one thing you may notice, and that is the fact that the collider, this capsule collider, is very large. So we need to basically shrink that down to fit the size of our player sprite. Now for this, we're going to select that component here. We're going to go into the details panel, down to where we have our capsule half height and capsule radius. I'm going to set the half height to be about 12. And I'm going to set the radius to be about 8. And yeah, capsule half height down to 12. So as you can see, this nicely fits the bounds. Nicely fits the bounds of our player right here. Okay, so we have our player, we have the collider. Now we need a camera. Okay, and this camera is going to basically be following the player around. Now, to have a camera that follows at a set distance, we are going to use the spring arm component. So I'm going to add a component here called spring arm, and this is basically going to control the position and direction offset from our player that the camera is going to be. So as a child of spring arm, we can add another component which is going to be of type camera. Okay, I'll make the camera a child of the spring arm here. And now you'll notice that the spring arm, when selected, has this red line coming out from the player, and wherever we move that, the camera will be offsetted based on that, same with rotation as well. So what we want to do is first of all rotate it so the camera is facing the player in the correct rotation here. We also then want to maybe bring the spring arm a little closer. So down here where we have target arm length, I'm going to set that to be 200 so that our camera is a bit closer to our sprite. And at the same time, we want to change some of our camera settings. So if I select the camera, what we're going to do is, well, first of all, the main setting we're going to change is the projection mode. So right here, you'll see projection mode is set to perspective, and this basically allows us to see depth, okay? You can notice here that with the sprite, the further I move away, the smaller it gets, okay? That might seem normal to us, and that's how basically all 3D games are rendered. So we can actually have depth, we can know, how far away a certain object is, yet with 2D, we don't really want to be rendering that depth. So what 2D games use is what's known as an orthographic camera, and that basically means that it is only going to render what it sees and not take into consideration depth. So no matter how far away we move from something, it's always going to remain the same size on screen. And that's really good with 2D because our size is typically defined by the size of the sprites when we create them. So I'm going to set the projection mode over to orthographic, and the ortho width to be about 400. This is basically going to be the amount of Unreal units that our screen is going to be wide. So we can then save this, click compile as well, go back to our level 1. Now, for our player to actually spawn into our world, we need a player start object. So we're going to go to place actors, we're going to look for player start, drag that into our level here, go back to the outliner. Now, when working in 2D, it's very important that whenever you add in a new object, you always want to center the positions, because right now you can see the player start is over here. We don't want it to be off center, okay? We want it to be in line with our tile map at all times. So in location, just make sure that the Y position is always going to be 0, so it is in line along that axis. We can then bring this up to about here. And one thing you'll notice is that, like with our player collider, it is very big. So we also want to shrink this down. I'm going to set this scale to be about 0.2 along all axes here. Okay, we can then bring this down to about maybe here. Okay. Now, for our player to actually spawn in, we need to set that up on our game mode blueprint. Okay, so we need to create one of those first of all. So in our blueprints folder, we're going to create a new blueprint class of type game mode base right here. I'm just going to call this one game mode main. Now, the game mode blueprint basically defines things such as the default player blueprint to spawn in, and other default blueprints as well. So if we open it up and go over to the details panel, you'll see here we have a list of classes, okay? And these are basically all of the default classes that are going to be used. So if we go down to our default pawn class, we want to change this over to our player. So that means that when our player spawns in, it's going to spawn in this specific blueprint. Click compile. We then want to go back to our level, but before we can press play, we need to actually assign this game mode. And to do this, we want to go over to the World Settings tab, which should be next to Details by default, and go down to where we have Game Mode Override. Now, we are going to set this to be our game mode main. We can save everything, press play, and as you can see, our player is in the world. Now, let's see if gravity works. So we'll set our player start to be up a bit here, press play again, and you can see our player falls down. But one thing you may notice, and that is the fact that our player is hovering above the ground, which we don't want that to happen, okay? So this is just an issue with, the 2D collisions. It's not exactly precise. So what we can do is go over to our player, select the sprite, and we are basically going to bring this sprite up a little bit, okay? Just so that the collider is going a bit below the player. So on our player sprite, we're going to set the Z position to be -2, so that our player sprite is down a little bit. Now, if we save that, go back to our main level and press play, you can see that our player is pretty much standing on the ground as they should. Okay, so let's bring our player start back down to the ground here. And in the next lesson, we are going to be implementing the ability to move around, jump, and have all of the cool player controls that we want in our platformer game. So thanks for watching, and I'll see you all then. Hey everyone, and welcome back. In this lesson, we are going to begin setting up our player controller, meaning we can actually walk around, jump, and, have fun in our level. So the first thing we're going to do before actually setting up our player's movement is setting up our inputs, because in order to move around, we need to know which keys are going to do what actions. Now, for our inputs, we're going to go to the content drawer, and we are going to create a brand new folder called inputs. Now, inside of inputs here, we're going to create a brand new asset. So we're going to right click, we're going to go input, and then input mapping context. Okay, and we're just going to call this our main input map. If we open this up, basically this is where we're going to list out our different mappings. So basically which keys we're going to use to move, which keys we're going to use for jump, dash, etc. And then what we can then do is create events inside of our player blueprint to listen for these inputs, and then we can run the respective nodes based on, if we want to move, if we want to jump, if we want to dash. To begin, what we're going to do is we are going to create our mappings for moving left and moving right. So I'm going to click on the plus next to mappings. I'm going to open it up, and I'm going to open this one up. And here what we're going to do is we are going to click on where it says none, and we are going to go down to where it says create new asset, input action. Okay, we're going to go to our inputs folder, and we're going to call this one move left. You can see here it has the name move left. We can then open this up, and you'll see here we have basically a key value. Now we can click on this little keyboard here, and to move left we are going to use the A key. Okay, so if we press A, that means the move left action is going to be triggered. Now we might also want an alternative way to move left with the left arrow key. Well, to do that, we can click on the plus next to the move left mapping, and we can then add in another key value here. Press that, click on the left arrow key. So if we press A or the left arrow key, the move left action is going to be triggered. Now let's do the same thing, but for move right. Next, set up the ability to have jump and dash. We can do that again. We'll create an input action for jump, and this one is going to be the W key or the up arrow, and then we're going to have one more, and this is going to be for dash. So we'll create a dash input action here, and the dash key, I reckon we are going to use the space bar, okay, like so. Okay, so here we have all of our mappings: move left, move right, jump, and dash, as well as their respective key values. Now what we need to do is assign this input map to our player character. So to do this, we are just going to exit out of it. We're going to go over to our player blueprint, and inside of our player blueprint, we are going to go over to the event graph. So up here where we have our viewport tab, we're going to go to the event graph tab, and here we have our default event nodes. For now, we are going to just get a begin play and move this up here a bit because this is the one we're going to use, and this gets called basically at the start of the game when the player has spawned in. And when the player spawns in, what we want to do is basically assign that input map to this player. So to do this, we first of all want to get our player controller. So we're going to create a get player controller node here. And we're going to plug this into the enhanced, okay, down here, get enhanced local player subsystem. So we're going to create that. And this is then going to plug into the add mapping context node, which is basically going to add this mapping context to our player controller. So we then want to set the mapping context to be our main input map, plug that into begin play, and there we go. So now basically what we're doing here is we are getting the main input map and we are assigning it to our player controller's input here. So then what we can do is start doing stuff based on those inputs. So for example, if we get the move left action, to basically trigger that, we can right click and type move left, and you should see here enhanced action events move left. So basically when the move left event is triggered, we can then do stuff. So for example, let's just plug this into a print node for now and just see what happens. Okay, so we can save that, compile it, press play. If I press the move left key, you can see that it is printing out the hello key, okay, like so. Okay, so we know that works. Now what we can do is actually move our player left when that event is triggered. Now to do this, all we need to do is call the add movement input node here, plug that in like so, and there we go. We also want to set our world direction to be 1 on the X, 0 on the Y, and 0 on the Z. Oh no, actually that means we're going to be moving right. We need to set this to be -1 in order to move left along the X axis. So if we save that, compile it, press play again, now when I move left, you'll see that we can move left, but we stop at the wall. So let's set up the ability to move right. So for this, we're going to add in the move right action right here. Plug this into the add movement input node and set the world direction to be 1, 0, 0. Now when we press play, or first of all compile then play, you'll notice we can move left, we can move right, but as you see we're moving very fast and I can, basically fall off the platform pretty easily. So we need to change a few of our movement settings. Now we're not going to do this in code by setting up a move speed variable or changing the scale value at all here. Instead, we're going to go over to our character movement component, which basically defines all of our movement settings, such as our gravity, our acceleration, our jumping, our walking, etc. So what we're going to do first of all is change our gravity scale down to 0.5, just because since our player is on a smaller scale than it would be in 3D, we want to basically scale down a lot of these things as well. We can then go down to where we have our max step height, which we're going to change to be 1 centimeter instead of 43. Otherwise, that means we'll be able to basically walk along any wall, stepping over it. Then down here where we have max walk speed, we're going to change that from 600 centimeters a second to 100, okay? So we're going to move a bit slower. We also then want to change our max acceleration from 2000 up to a very high number, such as 9000, 99999, just because we don't really want to have any acceleration in our player movement. Rather, we want our player to sort of be moving at its max speed at all times. So we can save that, compile it, press play, and now our player, as you can see, is moving basically as you would expect a 2D character to move, okay? They're sort of moving at a constant speed when we are moving left and right. Now, how about jumping? Well, for jumping, let's just move this stuff down over here. We can, of course, add in the, the input action jump command here. And what we're going to do is basically just call the jump function. So I'll plug this into the jump node right here, and there we go. So now we can save that, compile it, press play, and when I press W, as you can see, we are jumping, and we are jumping pretty high into the air, so we need to fix that. We'll open up our player movement component once again. We'll go down to where we have the jumping/falling section, and for where we have our jump Z velocity, we're going to set that to be 250. And air control, this basically defines how much control we have over our player when they are in the air. By default, it's very low, meaning we don't have much at all, but we want to be able to control our player left and right while they're in the air, so we're going to set this to be 1. And now we can move, we can jump, and as you can see, we can sort of still move around and jump like you would with any other player controller on it for a 2D platformer game. Okay, and if we see the max step height, you can see if we run into the wall here, we are not automatically stepping up onto it, which is pretty much what we want. Okay, we don't want the player to basically be automatically running up these steps when we are moving into it. We need to be able to jump in order to get over those obstacles. And there we go, that is the basics of our player controller right here. So let's have an overview of what we have done so far. We have set up our inputs up here with the input map, and then we have created the individual event nodes which get called when we press those respective actions. So when the move left, which is the A or left arrow key, is triggered, this event gets triggered, and that plugs into the add movement input node, which basically moves our pawn along a certain world direction, which is -1 along the x-axis. And that means moving left. And this is then, of course, multiplied by our move speed, the acceleration, and all that other stuff behind the scenes. Same thing for move right. Here we are moving along a positive x direction, and jump, we are basically calling the jump function right here, which is going to allow us to jump. Now, you may also notice that with this, we aren't able to double jump, and that is because this jump node is only going to get triggered if the player is standing on the ground. So that is what we have done so far with our movement. It seems pretty easy as we've only really used a few nodes, but later on, once we start setting up some more advanced stuff, we start fine-tuning our player controller a little bit, you'll notice that we are going to be improving upon these things, making them a bit more complex, adding in more functionality as well. So thanks for watching, and I'll see you all then in the next lesson.